Here we go. We have done all the array string problems, 2 pointers. Now we're at sliding window. I do not remember how to do sliding window problems. I will try my best. This is gonna be hard. I remember you need to be familiar with it. Oh, it's loading so slow. Okay, let's try. Minimum size subarray sum. The minimum length of a subarray whose sum is greater than or equal to the target. Okay. All positive integers, target is 7. So this has the minimum length. Okay, there's a follow-up, but let's do that later. Okay, so we have array of positive integers, they're not ordered. We need to find a subarray that adds up to at least the target, and we want the minimum length of that subarray. Okay, and we need to think with sliding window technique. Okay. I don't remember how to do sliding window though. Let's see if I can come up during this time. Let's say we start. Okay, we will have a window, so at least we need 2 pointers. So let's say we start the window like here. Okay, what if we do something like this? We start with 2. It's not reaching the target yet, so we expand our window to 3. Still not at 7. We expand 1 more. We're at 6. Expanding 1 more. Now we're at 8. We reached our target. We can store that. Right now we're using 4 elements, so the length of this subarray is 4. Okay. What do we do next? So we know that this window works. So if this window works, then we know for sure that if we expand it more, that would work as well. So when we're here, we have 8 plus 4, 12. We know that this works. So how about we shrink this window from the left side? So we see we have 12, we remove 2, now we have 10. We have 10, that still works. So let's try again and remove 3. And now we have 7, and we know that works. So now we have found a smaller window of length 3, so we can update that. Okay, and then we keep this window because this window is working. And then we continue to expand one more to the right. We have 10 again. We know that's bigger than what we need, so we shrink from the left. Now we have 9. We shrink from the left again. Now we have 7. Will this kind of algorithm always work? Okay, once we find a window that does satisfy the condition, well, since it is a subarray, we have to have this continuous part. So it makes sense to have this window that slides because that's gonna be a subarray. And we expand when we don't have enough. We can shrink it when we do to see what's the minimum window we need. And then once we have a minimum window, we can move to the right again to continue to look. I think that will be my algorithm. I'm not 100% convinced that that's explaining why it should work though. Let's write that. Maybe we'll get some more insights later. Let's see, we have a sliding window, so let's say we have left and right pointer. The left can start with 0 and right can start with 0 as well. Okay. Well, left is smaller than length of nums. I'm thinking we're gonna do this, right is gonna reach the end, but we're gonna do this until left even reaches the end. Right? Okay. Well, left pointer hasn't reached the end. We need a minimum length. Let's store that as result. If there is no such subarray, we return 0. So let's start with the result is 0. Okay, now we want to do the sliding window. We have a target. We need a running sum. We need a sum. Okay, what if we start from with the first number? Okay, window. Okay, so window starts from 0. Now it's adding the right element. Okay, let's just adjust along the way. So we have this window of 2 at the moment. If window is smaller than target, we want to increment right, and also what if we do like this? Okay, if window is smaller than target, then we increment right and add that to the window. Okay. Now, well, left. So left hasn't changed, so window is not window starts at 2, is not 5, and then it goes to 6, then it goes to 8. Okay, we're at 8. So now window is reaching the target. We're at 8. Okay, we're at 8. Right is at 3, left is at 0, length is 4. Oh, it cannot be. Can't start from 0. We need some kind of. Let's just use. We need like a maximum integer, something like that. Can we use that? How can we get the maximum integer? Okay, it says int has no max limit in Python 3. Okay. It seems like we could do something like infinite, math infinite. Not sure. Okay, guess we can try that. Import math. Okay, so if we find a subarray that exceeds this target, then we can do minimum that, or right minus left plus 1. So we found a subarray that satisfies the target, what do we do then? We store the length of that. Length is 4. Window is 8. I think now we should try to shrink the window from the left side until it no longer satisfies the target. Okay. Now, what do we do? Left. Okay, what if we increment left and window minus? Okay, so 8 minus 2. Now we have 6. We have 6 now. Left is a 1, right is at 3. We have window is 6. So do we continue in this loop or do we change it back, because now we don't have a Okay, so when we found this window that works, the length is 4. So if we keep this entire window and then whatever we add to the right will just be a longer window, so that will not give us any answer. So I guess it doesn't make sense to keep this entire window and continue to traverse. We could shrink this window to the left until it's no longer satisfying the target. Okay, so we have 6 now. 6 is smaller than target 7, so we expand on the right side again. Now we have right is at 4 and window is now 10. Okay, 10. Now next round, window exceeds target. So result will be the same length again, and we shrink the window again. Okay, so left is standing at 2 and window is at 7. Next round we will go in here because it is equal to target 7. So result would be 3. Okay, left increment again, window is now 6. Then we go in here, window smaller than target, we expand to the right, we have 9. Now next round, we are here, and then this is left, right, window is 7. Okay, next round, it's 7, we go in here, result is 2, left is now at the end, which is length minus 1. I think this might work. At least it looks like it's working for the first example. Let's try this. Okay. We also want to return 0 if there is no such subarray. So return I'm not sure if Python supports this. I'm sure there's the right syntax somewhere. So return if result is math infinite, then we return 0. Otherwise, we return result. That's the syntax for other languages. Let's see if this works for Python. I guess this is not the right syntax. Okay, so I don't know how it should be written. I'll look it up later. Let's just do if maybe this part is not working either. List index out of range, right? Which test case is it then? Oh, it doesn't say. Right. Okay. So, okay, let's say for this case, we are always gonna be smaller than target. We keep adding right. Okay. Interesting. It's returning 3. Oh. Oh wait. Left, right. Why would it be 3? Output 3. Okay, let's do this example. We have left, right, 0, result is math infinite, window starts from 1. So that's smaller than target, window. Oh, I see. I thought I changed it to 0 earlier. It's weird. Oh, it's still incorrect. Okay, see. So left 0, right 0, window is 0. Window smaller than target, window plus. Okay, window is now at 1, right is now at 1. Okay. Left, right, and window is at 1. Window is smaller than target. Window as 4. Window is at 5. Right is at 2. Oh, I see the problem. Okay, next round. Window exceeds target and the right is currently here, even though the window is here. So we actually don't need that. Still incorrect. Okay, we're still having some kind of index errors. Okay. So last time we were having left here, right there. Now left is 1, it's 2. Window is 4. Okay. Could we do something like this? We start with the first element, left, right. If it's smaller, then we expand the window. But right is at 2 again. Left, right. Oh, okay. Sorry, I'm now super focused. I'm so sleepy. Okay, let's get through this. Let's solve this. Left, right is at 0. Left smaller than. Okay, 0, 1. Window. Oh, I see. I switched the order of these two and now the whole logic's kind of different now. Yeah, I wanted to increment first and then So this is you increment and then you put it in the window, expand the window. Okay, so this was causing index out of range because this right could go out of range. So when right is at the last element, it will still go in here. Okay. So if right is at the last element, if that window is still smaller, then we really don't have any more elements to go. So there's no point in adding right and then doing the new window. So right actually has to be smaller than this. Wait, oh, so, okay. Alright. Okay, let's try. Should this still start with the first then? Okay, window left. So now left is out of range. So left is now out of range. Left. So what if left is at the last? Left is at the last one. Okay, let's try this logic first and refactor. If left is time limit exceeded. If left is smaller than length minus 1. So if left it would be so great to see which test this is. I suppose it's one of these. Okay. Print nums. Let's just see which test it is. Okay, left is at 0, right is at 0, then goes 0, 1, 2, 3. Now we have 8. Now we shrink 1, 3. 1, 4. 2, 4, that's good. Okay, 3, 4, that's right. 3, 5, 4, 5, 5, 5. Okay, so the problem is towards the end. Left is at 5, right is at 5. Result, left is 5, right is 5, and the current window is should be 3. So why would it go there? Let's print the window as well. Window is 2. Wait, window is 2. Six, 8. Oh, okay, 1, 3. 1, 3, window is 5. That's incorrect. Okay. Oh, I see. I think very interesting. We actually need to first to take away that from the window and then we increment. Interesting. Still incorrect. Output 0. Zero. Result. Alright, let's have a look at the result as well. Okay, one problem. We are at 5, 5, window is 3. That's correct. Why is result 1? Oh, right, we changed it back, so now we still need the actual right minus left plus 1. That's right. Okay. Alright, let's see. Now we do have result 2. Why is it returning 1? Oh, because right is actually at the last one. Okay, right is now at the last index, so it just went here instead and then calculated this. Okay, so right is at the last index. Window target. Okay. Output limit exceeded. Oh, okay, very interesting. So if right is at the last index, what do we do? Both left and right. I mean, we still want to check the last element, so that we need to do that. Right, if left is at 5, right is at 5, window is 3. If left is at the last index, I mean, we could break. Okay, so we are ending up somewhere here. Window is smaller than target, and then since right is now no longer, okay, so this is one, right is second to last. If right is at the last one, if right is at the last one, do we break them? Right is at the last one, what about left? Left, we can still continue to see if we can shrink from the left side. So we should break when, I'm thinking we should break when left is at the last index. Okay, that's what I'm thinking. Wow, this is taking such a long time. Okay, I think we're getting there though. It feels like we are on the right track, but still no. Oh my god. Okay. Still the first example. Right is 7 now. Right is 7. Left is 0. Oh, we're doing this one now. Okay. We are doing this one. Okay, so left is at 0, right is at 7. It goes in here. It goes in here. Why doesn't it break? So we need this to break if if right is at the last index and the current window does not reach the target, then we also need to break. Okay, so what do we do? Window does not reach target. This really doesn't look okay. Let's just make sure the logic works and then we can refactor. Still incorrect. Let's see. Left at 0, 0, 2. Zero, 1, 0, 3, 1. Okay, 1, 3, 1, 4, 2, 4. 3, 4, and then they stopped at 3, 4. Okay, 3, 4. Smaller than target. Right is length minus 2. Okay, right is not here. Window is not this. Oh, a broke. Okay. Finally got that right. Let's see. Okay. It worked, but it's extremely inefficient. Alright, I need to remove all the print. Okay. Okay, much better. We're no longer printing a lot of stuff, so that saves a lot of runtime. Let's run it one more time. 77%, it's totally fine. Back to 50, so still not that good. It's fine, but not perfect. Okay, so we have a solution. Let's try to refactor this. So we have left and right, we have results, window. Okay, let's give it 2 minutes. I'll see if I can refactor this. If window is smaller than target. Okay, if current window is still smaller and the right pointer has reached the end, then there's no way we can expand, so we get out of this. If the left pointer is at the end, then there's nothing more we can do either. So that explains this. Otherwise, space, we increment right pointer, we expand it to the right, put that into our window, and if it does reach the target, then we update this result. We shrink our window to from the left, we increment left. Okay, so that does look okay. Left, right. So this could definitely be refactored. Okay, I can't think of anything right now, so it's already been 50 minutes, so let's do time and space complexity, then let's have a look at the follow-up and top solutions. I'm afraid this is gonna be a long video. Okay, time, let's see. Left, right, start like this. We are gonna slide this window, expand it, shrink it, and then do this all the way towards the end. I actually don't know the time complexity of sliding window technique. It seems like it could be linear. Well, it's definitely between linear and quadratic. Okay, let's think about worst case scenario. Worst case scenario, we start this window like this. We expand. Okay, we expand. I mean, we could expand it all the way to the right, and then we shrink it all the way to the right again. We could also do, it could also happen that it expands, it shrinks, it expands, it shrinks, or something like expand, 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 shrink, shrink, shrink. I guess it should be linear because each element can only be expanded one time and then also get shrunk one time. Yeah, I think that's it. Since the right pointer is always gonna go forward to the right, and the left pointer is also only gonna go towards the right. So each element can at most be experiencing something like expanding it and then also shrinking it. Or it could be just expanding it and never gets the shrinking because it's part of the subarray towards the end. So I guess this will be linear time. Okay. Space. we are using constant space. No data structure is being used here. Okay, I think that's it for my solution. I'm not sure why it runs so slow though, if it's linear time. What is causing it? I mean, that's okay. Okay. Alright. Almost no time left. If you have figured out the linear solution, try coding another solution that is nlog n. Okay. So we wanna go towards the worst solution now? Nlog n solution. Nlog n solution. Usually if you see nlog n, it might have something to do with divide and conquer, some kind of binary search, some tree structure. Let's give it 1 minute. I'll just think about this for 1 minute. Okay. Nlog n. Nlog n. Well, I can't think of anything. Okay, let's just have a look at top solutions. Okay, linear solution to pointers, ij sum, integer max value. Yes, that's what I was looking for as well. Okay, while j, which I suppose is the right pointer, while j hasn't reached the end, sum, it's gonna add the right pointer and then right pointer get incremented. Okay, while the sum is bigger than target or equal, we update the target, we update the results, and we take away this and increment left. So this is exactly the same idea, same logic, just slightly different implementation. It did not need this part. Why is it that it doesn't need that part? Oh, okay. Let's have another look. First, we move until we get a window that reaches the target. Then we move left until it's smaller. Oh, one sec. Okay, I'm back. Okay. Since each element will be visited by left and right for at most once, that's why this algorithm is linear. Yes, that's what I was thinking earlier as well. So good to have it confirmed. It seems like it does not need this. I see, it's because it's doing a while loop in here. So it's gonna continue to move the left pointer until it becomes smaller than target. Then it doesn't need to go. So I'm not doing a while loop here, so I have to, for each round, if it's smaller, then I'll move the right one. And if it's bigger, I will move the left one. But here we do all of that in one go, so we will move this until it is smaller. So next time we're here, we know it is smaller. We can just increment on the right. Okay, I want to try that. Let's look at the follow-up. Accumulated sums of elements. Okay. Okay, I think I need more time to look through this. I will end the video here because it's already long. And okay, our first sliding window. I think we can get better at sliding windows. If we just practice, we know the basic framework, we will be able to solve it much better. So this is a good start. Okay, I will see you in the next one. Let me know if you have any questions.